Have you ever heard someone say it works on my machine when an app crashes somewhere else? Or wondered how big tech companies deploy updates hundreds of times a day without downtime? That's where containerization comes in. It solves one of the biggest headaches in software development, making sure your apps runs the same everywhere from a developer's laptop to a massive cloud server. In this video, we will break down what containerization is, why it is a game changer, and how it powers everything from microservices to modern cloud apps. So the containerization is the process of packaging application and their dependencies into an isolated, portable and lightweight unit called a container. It is a method of deploying and managing applications in isolated, lightweight environments that run consistently across any cloud infrastructure. Now, to truly understand containerization, we first need to understand how applications were traditionally deployed. In the past, the applications were typically installed directly onto a server or a virtual machine, which required us to manually configure the environment and install dependencies and ensure that everything worked together. This often led to challenges with environment inconsistency, resource inefficiency and scalability issues, especially when trying to move application across different environments or scale them quickly. Now let us see what are some notable differences in between the virtual machine and container. Imagine we have a virtual machine like it's a physical computer with some hardware resources. On top of that, we have host OS. It can be Windows, Linux or Mac OS. On top of that, we have hypervisor, which actually allow us to create or spin up the virtual machines and is also responsible for creating virtualized instances with virtual CPU, virtual RAM and virtual storage, which we are going to take out of our physical computer hardware resources to create the virtual machine. On top of hypervisor, we have guest OS, and finally we have our application. Through hypervisor, we can enable our virtualization and create multiple virtual machines for each platform, like we have Windows, Linux and Mac OS. In this way, we can create multiple virtual machines which are running independently in some isolated environment. In which like one virtual machine is unaware of the other. In containers, like we have a physical computer with some hardware resources. On top of that, we have kernel, which will help our software and hardware talk to each other. On top of that, we have host OS operating system. And on top of that, we are going to create multiple containers. And the best thing is that each container will share the host operating system and kernel, and each container will contain everything what it needs to run, like it will contain the runtime, the libraries or the scripts and the code. So each container will contain everything that it needs to be run. And these containers are isolated from each other with the help of namespace and C group. So what is the namespace? Like it isolate a container's view of system resources like processes, network and file systems. They ensure each container operate in its own private environment, unaware of other containers. And C groups, like it's a control group, are essential for managing the resources that container consume, ensuring that one container doesn't overuse system resources and impact other containers or the host system. So this is about the notable differences of the virtual machine and the containers. Now let us understand how container works. For each system, we have a hardware resources, host operating system or kernel on top of that. And on top of that, we have a container engine. Now there are different types of container engines, like we have Docker engine, Kubernetes pods. Let us take an example of the Docker engine. So Docker engine will refer the Docker file. So Docker file define a container. Like let us take an example of the Docker file in which we can mention the base image, dependencies, application code and the command to run the app. So with the help of this Docker image, like Docker engine will create the container. Now next we can use this docker build command with this command, it will create a Docker image, and we can run the Docker image using this docker run command. Once we run the image, it will launch a container for that image, and this way we can create multiple containers out of the Docker images. Now in this, like Docker engine will refer the Docker file, and inside the Docker file we are going to define the container definition, like it is going to tell the Docker engine like how it should create the containers. So that definition we are going to define inside the Docker file. And finally we can use the docker build command to create the Docker image, and we can run the Docker image to create the containers. So this is about how overall the containerization works and how it will create the images and launch the containers out of it. Now let us see what are the benefits of using containerization. First is the portability. Containers run the same way on any environment like development, production and testing. So we can package the application with all its dependencies and run the same way on any environment. Next is a lightweight. Containers share the host OS and kernel, so they are much smaller and faster than virtual machines. They start in seconds, making them ideal for scaling and automation as well. Next is the scalability and efficiency. Containers can be scaled up and down based on the demand using orchestration tools like Kubernetes. Next is isolation, like containers run in its own environment, isolated from other containers and the host system. Next is a microservice architecture. As we know that monolith application, we can add all the application related code inside one application in monolithic architecture. But if we want to break down the monolithic architecture, we need to create multiple services out of that, and we need the containers which will allow each microservice to run independently within its own environment. So in that for that case, this containerization will help and support the microservices architecture, which will help and run the multiple services in independent containers or environments. Next is the cloud native applications, like containers enable applications to run consistently on any infrastructure like on-prem, public cloud or hybrid cloud, and cloud native development as well. And finally, improve the resource utilization. Containers can pack multiple workloads tightly on the same hardware, improving overall system utilization and reducing the infrastructure cost compared to virtual machines. So these are some important or notable benefits of containerization. I hope you must have enjoyed this. Please do not forget to like, subscribe and share. Thank you so much for watching.